Have you ever wondered what is the difference between the standard deviation, the standard error, and confidence intervals? Then you're in the right place. Basically, we distinguish between measures of variability and measures of uncertainty. Variability is just a natural variation between measurements. For example, not all people have the same height. Some are smaller and some are taller. That's variability, the variation between measurements or the variation within your sample. Perfect measures of variability are the standard deviation for normally distributed data, or percentiles, which can also be used for non-normally distributed data. In charts, we usually plot variability using error bars or whiskers. Small error bars mean small variability. In summary, these measures describe variability, or you could say the natural variation. So what is uncertainty? Imagine you want to determine the average height of adult humans. Let's not distinguish between gender to keep it simple. You might measure height in 10 different subjects and then obtain a mean height. However, does this mean really describe the average of all adults on this planet? Which mean would we get if we had measured in 10 different subjects? We would probably have obtained a different mean value. Or maybe 10 subjects is not enough, so let's measure 20 subjects. Then again, we would obtain a different mean height. You get the point. Basically, whatever we measure, our sample will always be limited, and there is always some uncertainty whether our mean value describes the true mean for all adults on this earth or not. Measures of uncertainty describe just that uncertainty. They provide, let's say, a range within which the true value is located. A typical measure of uncertainty is the standard error. The standard error can be explained as follows. Imagine you have repeated measuring height in 10 subjects 5 times. So you have obtained 5 different mean values. Now, mathematically, the standard error is just the standard deviation of these 5 mean values. That is, it describes the variability around the overall mean. This might be confusing because before we said the standard deviation describes variability, so let's be more precise. The standard deviation of individual measurements describes variability. In contrast, the standard error is, mathematically, the standard deviation of these 5 mean values. So in summary, the standard error describes the uncertainty of the mean. If someone asks you, how much does the height of people vary? Then you can show them the standard deviation. If someone asks instead, how sure are you that your mean value is representative for the whole population of adults on this planet? Then you can show them the standard error. Another way of memorizing this is the standard deviation describes the variation within your sample. That's variability. The standard error describes the variation between samples. That's the uncertainty. Confidence intervals. So we have learned that the standard error is a measure to describe the uncertainty of a mean value measured in a sample. It's only a single value. But sometimes we are interested to know more precisely in which range the true value will be located with which probability. This is what the confidence intervals are expressing. When we present a 90% confidence interval of the mean value, then that means that our true mean value will be located within this interval with a 90% probability. So also the confidence interval shows us uncertainty, but we can provide a percentage. Now we can calculate confidence intervals not only for the mean value, we can use them to describe uncertainty of any parameter. For example, the confidence interval of the median or of a percentile, or the confidence interval of a function parameter, estimated during curve fitting. Hence, we always have to be precise and indicate about which parameter we are talking. So this was an overview of measures of variability and uncertainty. Thank you for watching, and if you liked the video, please like, share and subscribe.